Today we get to talk about the surface area and the volume of pyramids and cones. Okay, good. So first of all, we want to, whenever we're finding the surface area of a pyramid, it has to have a regular base, meaning all the sides have to be equal. Okay, this formula only works when the base is a regular polygon. Okay, so tell me, what's a regular polygon with 4 sides called? Better than a parallelogram. Regular means all the sides are equal. A square. A square is going to have all equal sides, and not just all equal sides, but all equal angles. Okay? So for this to work, to be able to use this formula, it has to be a regular polygon. In this case, a square. So we have a square pyramid. And yesterday, when we were working with cylinders or with prisms, we had L equals P times H, right? Now it's different. What's L? L is the slant height. Okay? So it's not the height that comes from the peak of the pyramid to the middle of the base. It's actually the slant height. So it's not perpendicular to the base at the center of the base. It's perpendicular to one of the base's edges. Okay? So it's one of the slant heights. If you were sliding down the pyramid, that's where you would be. So far, so good? So we have to notice the difference between L and H when we're working on these problems today. And most of the time, we'll give you L. Sometimes we'll ask you to find it. Okay? So perimeter is still perimeter. The half comes from the fact that if I had a square pyramid, a square prism, what kind of faces do I have? Rectangles, right? Okay. The bases the bases are squares, but the faces are rectangles, right? So we take the perimeter of the base times the height to get all 4 of those rectangles. But now we're taking the perimeter of the base times the slant height, so we're getting triangles instead. And what's the area of a triangle's formula? Base times height divided by 2. Not base times height, but base times height divided by 2. That's where that half comes from. Make sense? We now have triangles, not rectangles anymore. Okay? So let's put it into play. How are we going to find the perimeter of this square? Add them all up. You can either add 12 4 times, or you can take 4 times 12. So what's 4 times 12? 48. So the perimeter was 4 times 12, or 48. And what's the slant height of this guy? 14. So you can take half of 48 and then take that times the 14, or you can take 48 times 14 and then at the end divide by 2. So what's 24 times 14? So 336 meters squared is our lateral area. Okay. Now we're going to resubstitute that in. We already found it, so there's no sense in recalculating it. And now we just have to find the area of one base. How do you find the area of a square? Multiply the 2 sides together. Length times width, base times height, side times side, right? So what is 12 times 12? So we're going to add 144 to our 336. And what do we get? Or 80 meters squared. Not so bad, right? Okay. Especially after what we've been doing. This is not too bad. Okay. Next example. Do the one right below it. So write your formula. L equals half PL. And T equals half PL plus a capital B. And substitute your numbers in. the capital P is always the perimeter of the base. And since this is a square again, because it has to be a regular polygon to make this a pyramid, so for this formula to work, each of those sides is going to be 7. So you're finding both L and T of the second one that goes straight down. We're working the left side first. We're working down. All right, so we had four sides that were equal to 7. So our perimeter of our base is 28. 4 times 7 is 28. We take 28 and we can divide that by 2 since it's even. Okay? Because there are 4 sides that are each 7. Okay? So we can add 7 plus 7 plus 7 plus 7, or just take 4 times 7. So half of 28 times 5 is 14 times 5. Everybody get 70 square centimeters? Okay. Now, we've already found that, so no need to find it again. We just substitute it in. And now we have to find the area of the base. How do we find the area of a square? Multiply. So 49. So 119 centimeters squared. Easy peasy? Okay, these aren't bad, right? Okay, so the next one. Next one we need to do is find the volume. Okay, the volume is going to be 1/3 the base times the height, where B is the area of the base. And this time, H is not the slant height, it's the perpendicular height from the center of the pyramid, or from the vertex of the pyramid to the center of the base. Okay. So 1/3, because it takes 3 of these pyramids to be able to fill up one prism of the same height with the same base. Okay? Doesn't have as much stuff inside. So when we want to find the volume of this particular pyramid, we're saying 1/3. Now this time it doesn't have to be a regular base, a regular polygon for the base. It can be a rectangle. So how do you find the area of a rectangle? Length times width. So we're going to take the 15 times the 9. Okay, so 15 times 9 is going to get us 135. So 1/3 times 135 times the vertical height this time, the perpendicular height, not the slant height. So times 8.5. And so you can either take 1/3, 1 divided by 3, times these two, or you can say 135 times 8.5 divided by 3, and we get what? If we take 135 times the 8.5, and then we divide that by 3, .5. And it's going to be inches cubed now because it's volume. We took inches times inches times inches. Okay? Exactly. Feeling good? Okay. So now we've got to talk about cones. Okay? Cones. So when you think about, what are they called? Those ice cream cones that have drumsticks, yes. Okay? You think about the drumsticks, you have that wrapper, right? That wrapper is the keeping you from getting all messy, and then it has a circle on the top, right? So with this drumstick or with a cone, the lateral area is pi r l, pi times r times l. Okay, so pi times the radius times the slant height. We can leave it in terms of pi. We do not have to multiply 3.14 or the pi button on our calculator. So we're just going to say pi times, what's the radius? And what's the slant height? So 3 times 5 is 15 pi is our answer. It goes down the side of the pyramid or down the side of the cone. Yep, this dotted line is your perpendicular height, and 5 inches was your slant height. So far, so good? Okay, to find the total surface area, we take that pi RL, and we add a circle, right? The top of our cone is going to have a circle on top. So we're going to take that 15 pi that we just found, and we're going to add on a circle. Area of a circle is pi r squared. So pi times, what's our radius? So 3 squared is, so 15 pi plus 9 pi gets us 24 pi. They're like terms. They both have pi's in common, so we can add the numbers in front and write the pi behind it. Questions on this one? All right, let's do, oops. You don't have to do anything with the pi. That's the exact answer. I mean, if it makes you feel better to multiply it in, you can. But this is the exact answer. It's a lot cleaner, and you don't have to think so much, and you don't have to, use the brain cycles or the calculator cycles to put it in. Okay? So I like this answer better. Some of the other geometry teachers are asking students to multiply it in. I don't see the need. And in Algebra 2, you'll like to have the pi's in there out of it anyway. Okay? All right, so next one. Your turn. Find the lateral area and the surface area of this cone. First, write your formula, because as you can see, we're getting lots of formulas now. And the more you write them, the more you'll remember them. Absolutely. You don't have to tell me that you got, I know that your perimeter was this, and I can look and see what you did. Okay, good. Okay, so pi RL. All right, so what was R? So when we take 4 times 7, we get 28 pi square inches. Everybody get that? Okay. Now to find the total surface area, we need that pi RL, and we need to add on one base. Okay. So what's one base going to be? Pi r squared, right? What's the radius? 4 squared is, so we're taking 28 pi, and we're adding on 16 pi, and we're getting, don't forget your pi. Okay. Now, why is it pi RL? Okay. Yep, radius and slant height, right? So on our pyramid, it was 1/2 the perimeter times the slant height. What's the perimeter of a circle? Circumference, right? And so if it's the circumference, that's 2 pi r, isn't it? So isn't 1/2 times 2 pi r the same thing as pi r, right? And then we add our L. That's where that comes from. All right, last example. Let's find the volume. So to find the volume, you have to have which height? The perpendicular, the middle one, okay? The one that goes from the vertex to the middle of the circle, to the center of the circle, okay? So sometimes they're going to try to trip you up and give you the slant height and ask you for the volume. Don't let them. You know how to find the slant, or how to find the regular height, okay? So what did they do here? They tried to trip you up again and gave you what? The diameter. So instead of the diameter, we need the radius. What's the radius? 6.5. Okay, so my volume formula is 1/3, just like it was before for the volume of a pyramid, right? But it's going to be pi r squared h. Pi r squared is the same thing as capital B, isn't it? So we find the area of a circle by taking pi r squared. So 1/3 divided by 3. Yeah, at the end. Yep. So whatever we do, if whatever we get for 6.5 squared times the perpendicular height, 18, at the very end we want to divide that by 3. So 6.5 squared gets us, so 42.25 times 18 divided by 3, or times 6, is going to get us 253.5 pi inches cubed. Okay? Not too bad, right? Yeah, we're getting used to these as part of it. We're getting used to what we have to do, but also some of these formulas are easier than others, and prisms are probably the most difficult of all. Okay? All right, assignments coming at you. I want to show you a couple things. We're not going to work the problems, but I want to show you a couple more slides. Okay? Hang with me for just a second while I'm passing this out. Okay? Volume we just did. No big deal there. What if it's a slanted cone? Is the volume going to change? No, it didn't change with pyramids, did it? So we still use which height for the volume of a cone? The perpendicular height, the one from the center, right? So we don't want a slant height. We want to use for the volume a perpendicular height. Okay? All right, your assignment is this worksheet. Make sure you write your formula down, then substitute your numbers in, and then add your label.